Hi there, this video is going to explain why size matters. Size matters with electrical resistor components. It's not just the opposition to current flow, the ohmic rating, it's also the physical size, the watt rating, the I squared R heat dissipation that the resistor can physically handle. What we've got here is we've got an 8.2 ohm resistor here. We can see against this ruler here that it's the body of it is quite small. It's about 7 mil long. It's only a couple of mil diameter. It's physically quite small. This resistor is probably rated about half a watt. What we've got here is 3 volts across it. If you do the Ohm's law, 3 volts divided by 8.2 ohms is going to give you about 0.36 amps. And the wattage of that is going to be about 1.1 watts. So this is the wattage, the heat dissipation of this resistor is higher than the actual intended rating of it. So what we've got is Ohm's law, 3 volts divided by 8.2 ohms, 0.375 amps. We can see that on the meter. I squared R is the heat dissipation. It's about 1.125 watts. Now this resistor is probably by its size half a watt resistor. It is taking that current, it is getting hot, but it is taking it so far, although it's above the rating. If we up the voltage a little bit, let's see what happens to that resistor. Starts to smoke, okay? We obviously don't want that. That resistor is being damaged now. It's not fit for purpose because it's been damaged because it doesn't have the physical volume to dissipate the heat. Okay, let's now go with 2 resistors in series. What we've got here is 2.2 and 6.8 that add up in series to give us approximately 9 ohms. Now if we connect that into the same circuit, we turn the voltage back up to 3. So if we turn it up to 3, we should get pretty much the same current. It's 9 ohms, so we're getting a bit less than last time. But these resistors sit there quite happily. They are getting a bit warm. I would say these are 1 watt resistors just by the physical size. You can see that the actual length is of that resistor is now double what it was earlier. It's about 14-15 mil. You can see has a much bigger volume, and it will dissipate a lot more heat. Let's turn the voltage up to, let's turn it up to 6, and let's see if they'll be quite happy at sitting there. Sitting there at 6, I would say these are 1 watt resistors. What have we got now when we have 6 volts and we have 9 ohms? From Ohm's law, we've got a current flowing of 0.67. I squared R gives us 4 watts. So we've got 4 watts dissipation in total. We've got 2.2 ohm here, 6.8. So we've split the power dissipation between 2 resistors. Yeah, they are getting warm, but they are taking that heat dissipation of 4 watts at 6 volts, and they are sitting there without self-destructing because they are rated at least 1 watt each. And they're sitting there, they are getting a bit warm. Yeah, they're over the rating, but they're not self-destructing. Okay, so what happens next? Let's see if we got an even bigger resistor. So what we've got now is a 100 watt rated resistor. These Arcol chassis resistors are physically quite big. So we're talking, it's about 70 mil long. It's got a physically large body on it. What we've got now is it's an 8 ohm resistor. We have 6 volts here, and it's 8 ohms, and it's sitting there quite happily taking that. It is getting a little bit warm, but there aren't any issues with that. If we turn it up, let's turn it up to 10. Turn it up to 10. Oh, we're current limited. Turn it limited. Turn it up to 10 volts. 10 volts. Turn it down. At 10 volts, we're taking 1.1 1.25 amps. We can see 10 volts divided by 8, we've got 1.25 amps. So the I squared R is going to be 1.25 squared times 8. So that's going to be dissipating 12 watts. So that's now a 12 watt dissipation on this 100 watt rated resistor. So it is getting a bit warm, but it's totally happy there because it's got the physical size to dissipate over 12 watts as is intended. What if we double the voltage? We probably reach the limits of this power supply. We double the voltage up to 20 volts. We're beginning to hit the current limit there. Turn that down. 20 volts. Yeah, 20 volts, turn it down. So we've now got 2.5 amps here. So we're now dissipating about 25 watts. This is a 100 watt rated resistor. You can see it's physically quite large. It's taken that wattage without any problems. It is getting a bit warm, but it's going to sit there quite happily. It's not going to be damaged. It's dissipating 25 watts, 20 volts at 2.5 amps. And it'll get a bit warm, but it's quite happy. It's not going to be damaged in any way. So size matters with resistors. It's not just the ohmic value. You need to have the correct wattage rating with the resistors as well. So the size matters. Thank you for watching.